Hello, my name is Juan Carlos Lopez. I'm an aerospace engineer for the NASA Johnson Space Center, and today I would like to talk to you about inflatable structures. NASA is getting ready to launch the first human-rated inflatable structure to the International Space Station, and we're really excited about this. So join me to see and explore some of the wonders of inflatable technologies. This presentation is entitled Living in a Space Balloon from Cartoon to Reality. First of all, I would like to tell you a little bit about myself. I was actually born in Garden Grove, California back in 1990, but I was raised in Delicia, Chihuahua, Mexico. I lived in Mexico till the age of 16, and at the age of 16 I decided to immigrate to the United States because I wanted to learn English and pursue an education. So at the age of 16 I moved to El Paso, Texas. I finished high school in the US, and then I eventually went to the University of Texas at El Paso, where I graduated as a mechanical engineer in December of 2012. Since then, I've been working in the NASA Johnson Space Center as a structural loads and dynamics engineer for the Johnson Space Center. Some of the things I do through the structural engineering division is F equals ma, force equals mass times acceleration. My group is known as the group of Newton's second law. Essentially what we do is that we analyze the environments that are going to affect the rockets and the forces that those environments producing the structures. And what we do is we analyze the accelerations or the vibrations of the rockets in different points and different stages from liftoff to re-entry to Earth. And by analyzing these vibrations, we essentially make sure that the structures and the crew that is traveling aboard the rockets and the spacecraft that we designed, that crew and those systems won't be affected by the vibrations of the rockets. So as I mentioned earlier, NASA is getting ready to launch the first inflatable module to the International Space Station. And we're really excited about this. This is gonna make history, and it's gonna be on history books. So let me share some of the advantages of using inflatable structures. First of all, I wanted to ask you this question. Will you trust an inflatable structure? You know, a lot of people think that inflatables will pop like balloons do. So some of the things that NASA is getting ready to do is to create inflatables that will save NASA volume and mass, but at the same time that will be reliable enough to not pop in space. As I mentioned, some of the advantages of using, for example, a wooden chair versus an inflatable chair is that you can deflate the chair, the inflatable chair, you can fold it, and you can put it in a smaller rocket. The same thing between the volume that you get in a beach balloon and a watermelon. You know, you can deflate the beach balloon, you can fold it, and you can put it in a smaller rocket. By doing that, you save space, you save mass, and you save volume. And by doing that, you also save money. And NASA is big about saving money. So if you can do that, you know, that's a really big advantage for space exploration. And that's the reason why NASA is exploring inflatable structures as a ways and means to live in space and send humans to Mars and destinations beyond. NASA has already explored different inflatable technologies like spacesuits. Spacesuits are things that are deflated. You know, you can fold them and you can put them in small volumes. And then when you get to space and the astronauts put them on, you can pressurize them, and then you have a well-defined shape that astronauts can breathe and live in. So those are some of the inflatable technologies that NASA has already developed and implemented. Inflatable technologies are not new. Back in 1952, a scientist named von Braun actually proposed the first inflatable space station. This space station had a volume of about 75 meters in diameter, dimensions of 75 meters in diameter, and had a capacity of about 18,000 cubic meters, which could hold up to 80 people or 80 astronauts at a time. Some of these technologies, essentially, this space station proposed the first inflatable sections made of reinforced rubber, and also an artificial gravity, technologies for artificial gravity that essentially rotated and produced artificial gravity in space. Even though this space station was never built by NASA, it inspired a lot of people in the science fiction community to actually put this space station in movies and other different science fiction projects. One of the examples is the 2001 Space Odyssey space station that was filmed in the 1960s. If you see that space station, that space station was essentially modeled after Von Braun's space station. If you also look at more recent movies like Elysium that was released in 2015, you will see that those inflatable space stations that had artificial gravity produced by a rotation along the center point of the structure. And then you have also movies like Interstellar, that even though it wasn't an inflatable space station, it followed Von Braun's suggestion of creating artificial gravity in space through the rotation of the outer circle of the structure. In addition to that, these inflatable technologies have inspired NASA to create other things. Even though we didn't create inflatable space stations, we have created other things with these technologies. In 1956, NASA, or its predecessor, NACA, N-A-C-A, produced a communication satellite program called ECO. These communication satellites essentially look like giant balloons. These inflatable balloons were made out of aluminum polyester with about 31 meters in diameter, and you can see a picture in the presentation. NASA launched two inflatable communication satellites. The first one was ECO-1 in 1960, and the second one was ECO-2 in 1964. So this tells you some of the history of inflatable technologies that are leading up to the first inflatable module in the International Space Station. And I joke around that this ECO satellites actually look like the Death Star from Star Wars that was released back in 1977. In addition to these communication satellites, NASA experimented for several years on inflatable technologies. In 1961, NASA produced the first inflatable station concept in collaboration with Goodyear, the tire company, Goodyear. In 1961, the U.S. House Committee on Science and Astronautics essentially told NASA to rather focus on aluminum and can-looking modules instead of experimenting with inflatable technologies. This decision was made not necessarily because they thought inflatable technologies were useless, but because there was a political motive to just focus on aluminum and metal-looking technologies rather than inflatables. So for several years, NASA essentially abandoned the idea of using inflatables for human space exploration. Nevertheless, between 1961 and 1969, NASA actually produced different prototypes using inflatable technologies. One of them was the inflatable paraglide for the Gemini missions. In addition to that, the inflatable airbags that were using the Apollo capsule during landing in water were also some of the results of Von Braun's inflatable technology suggestions. In addition to that, NASA has always thought of using inflatable technologies to build habitats in the moon and also habitats in Mars. Nevertheless, this will be the first time in human history that inflatable structures will be used in space to accommodate astronauts and humans. Another one of the concepts that NASA developed back in the 70s and 80s was the TransHab concept. That is actually a predecessor of the inflatable structure that we're going to be launching next year. This TransHab technology had different modules that could accommodate different astronauts to perform a variety of activities. The TransHab module had an exercise area for astronauts, also different laboratories where astronauts could could produce scientific experiments in space, similar to the modules that we have aboard the International Space Station. And again, one of the advantages of inflatable technologies is that they're not as heavy as the modules that we currently use aboard the International Space Station. Some of the learnings from this TransHab technology is the concept of using different layers. TransHab have different layers that have different capabilities. We have a layer that essentially keeps the inflatable structure and gives it its shape. You know, it gives it this round shape similar to the one of metallic space modules. You also have a layer that protects against micrometeorite strikes. In addition to that, you have a layer to protect against high temperatures or low temperatures to keep the inside of the inflatable capsule and the inflatable structure pretty much isolated from the changes in temperature. In addition to that, you have other layers for radiation protection and so on and so forth. So this TransHab technology, even though it didn't lead to something that we flew to space, it was a learning lesson to learn about the advantage of having different layers in our inflatable structures. We actually, back in the 80s and 90s, NASA performed different tests in this TransHab technologies, in these inflatable technologies. We did a test where we put it in a vacuum chamber and we performed a structural integrity test in order to make sure that the different layers wouldn't damage the structure, the structural integrity of inflatable technologies. And there were a variety of different tests that were performed to test the capabilities of this TransHab technology. So even though we didn't flew the TransHab to space, we actually sold the rights to some of this technology to Bigelow Aerospace. Bigelow bought the exclusive rights of the TransHab technology for low Earth orbit, or LEO, exploration. In 2006 and 2007, Bigelow launched Genesis 1 and 2, and these were the first inflatable structures to ever fly to space. Nevertheless, those structures were utilized by humans or by astronauts. Bigelow is currently getting ready to launch the first human-rated inflatable structure, which is called the Bigelow Expandable Activity Module, the BEAM. This BEAM concept is really similar to the TransHab technology. Nevertheless, Bigelow has been optimizing the designs and making it bigger and better. This is a video of the beam being attached to the International Space Station. As you can see, the space station is going to attach to one of the modules aboard the International, the beam is going to attach to one of the modules attached to the International Space Station. We're going to use a robotic arm to take the beam, attach it to this module in the International Space Station, and then also help it expand so that it takes its shape and pressurize so that astronauts can eventually use it. This beam concept is gonna set a precedent on the use of inflatable technologies for human space exploration that we can eventually use to Mars, to go to an asteroid and destinations beyond. Bigelow has different ideas on how they can use these inflatable structures. They actually plan to take this beam concept and make it bigger and build an international space station built by different inflatable modules. This space station, called the Olympus, will actually allow Bigelow to send tourists and send people like you and I to space, you know, to go on a vacation on his hotel in space. In addition to that, NASA has different ideas on how we can use inflatable technologies to capture an asteroid and then send humans to go to the asteroid and analyze it. In addition to that, as I mentioned earlier, back in the 80s, the 60s and 70s, NASA had the idea of using inflatable technologies to set permanent habitats in the moon and Mars. And this is an idea that NASA hasn't abandoned. We believe that we can use these technologies to save on volume, save on mass, and also save on the cost of sending these structures to space. And we believe they can be as efficient and effective as metal or aluminum made habitats. In addition to that, we have a lot of plans to use these technologies for Mars. In fact, the Spirit rover that got to Mars in 2004 used inflatable technologies to land on the surface of Mars. If you ever watch a video, you can see whenever the Spirit touches ground, there's a bunch of balloons that inflate, and then they bounce for a variety of miles, for a lot of miles, and then it eventually comes to rest. This inflatable technologies essentially protected the Spirit rover from impacting into the surface of Mars. In addition to that, NASA has the idea of using inflatable technologies for protecting during entry on the Martian atmosphere. And in addition to that, there's private companies like Inspiration Mars that are essentially thinking of using inflatable technologies as habitats and service modules that astronauts can use during their voyage and their travel to Mars. And you know, these inflatable technologies continue to inspire people in the scientific community and also on the sci-fi community, on the science fiction community, as ways for astronauts to live in space. And a clear example of that is the book The Martian, written by Andy Weir. And the structure that he describes is essentially an inflatable. So I hope you liked the presentation. If you want more information, I encourage you to look at NASA's website, www.nasa.gov. And I also invite you to follow me on Twitter using with my username JC Lopez NASA to continue learning about inflatable technologies and some of the contributions that I've been able to make this Bigelow expandable activity module project happen. So if you have any questions, feel free to follow me on Twitter, and we will see you next time for another presentation. I hope you enjoyed it. Bye.